Hello everyone. Today we have the chapter of carbon and its compounds. So, what is basically carbon and its compounds? Before starting the chapter, we will have a short quiz. Let's get started. Carbon compounds. My name is Gurdeep Singh. So the first question is, what is the difference in a molecular formula of any two consecutive members of a homologous series of organic compounds? So basically, let's see the solution. So let me draw here two homologous of the alkane. Here's the alkane of methane, and one here is ethane. Methane and ethane. So when we write the formula, it's CH4. Let me change the color. C2H6. CH4 and C2H6. So when we clearly see, there is C plus C and H4 plus H2. So the difference, we need the difference here. Difference would be CH2. That's the answer. Done. Sorry. Switch back. Okay. I will save it for a moment. Okay, now soaps and detergents are both types of salts. State the difference between two. Write the mechanism of cleaning action of soap. Why do soaps not form lather with hard water? Mention two problems that arise due to the use of detergents instead of soaps. So a big question. Now, generally it should come for around 5 marks are expected from this question, and come for 3 solution. Soaps and detergents, two types of salts. So what is the exact definition of salts? Let me write the exact definition first. Soaps are salts of higher fatty acids of calcium. Okay, first question. Here till here we have done. Difference between the two is soaps are biodegradable in nature. Right. One more thing is that soaps only work in soft water, while detergents work both with hard water and soft water. Detergents are non-biodegradable, means similar to opposite of these points. Now let me erase all this. Completed first part, we have done the second part, difference done, and just one diagram. A revision lecture, not in detail. In CBSE, you can draw like this. So the actual structure of a soap, how we draw this actual structure is like somewhere like this. A double bond and single bond. That's for structure, and this is a fixture structure which we make till 10th. Let me just hide this for a moment. And mechanism. Oops. Yes. When I draw soap structure, these structures are known as mycelials. These hydrophobic tails do not like water, let on the grease or the oil stain, and all this water around attracts the ionic ends. Ionic ones. So when they go off, take a small speck of dirt with along with them, dirt, take it along so that carbon compound. So when we see the solution of this, why do soaps not form lather with hard water is simple, that soaps do not work in hard water as they form scum. Now name the compound formed in ethanol is bombic ethanoic acid, presence of concentrated H2SO4. So only a reaction is needed here. C2H5OH plus CH3COOH gives out in concentrated H2SO4. We get C2H5CH3COO plus H2O. This is known as dehydration reaction, through which a sweet swelling compound known as ester or ethyl ethanoate is formed. This ester is used in the formation of perfumes. Draw the structure CH3COOH molecule. Easiest of all. Two carbon atoms are given, and this is doubly bonded by O. And on one side it has OH. Done. If this has fulfilled its valencies, just need to satisfy with hydrogen the rest of the valencies. The structure, not the electron dot structure. So here is the structure of ethanoic or acetic. Just box the structure after completion. Just write structure. Done. State two characteristic feature of carbon which when put together give rise to large number of carbon compounds. So why are these carbon compounds are formed? So we need to figure out the characteristic features. There are just two characteristic features. One is tetra valency, other is the process of self-linking to form change as is catenation. Here this means catenation means carbon can make bonds with itself from 2 to 5,000 carbon chains. Yes. Tetravalency means 4 valence electrons. Okay. What is an esterification reaction? Done already, so no need to do it again. Out of HCl and CH3OH, which is a weak acid and why? Now HCl and CH3COOH. Here we see whenever we need to see an acid, the best trick to remember weak or strong acid is the number of hydrogen atoms. Simply count the number. In here it is 1, but in here it is 4. The least the hydrogen atom would be, the higher acidic it would be on the pH scale. That is when power of hydrogen. When power of hydrogen is 0, then it's the strongest acid. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and this makes 1, so it belongs to category 1. This belongs to somewhere 4, hence it is a weaker acid. This is acetic acid, and this is hydrochloric acid. Explain isomerism. State any forecast. Nothing. Isomerism is the manipulation of structures, manipulation of carbon compounds where they have different structural formulas but same chemical properties. Here we'll take an example of butane. Here it is written possible isomers of butane. So we get, just add H after 4 first, the regular butane. Okay, now the second structure, which is isobutane. Only butane and pentane are asked generally. So hello, Anji. So we have just 2 slides left. Let's start isomerism. I have done. No need to do it again. Name the oxidizing used in the conversion of ethanol. Name an oxidizing agent used in the conversion of ethanol to ethanoic acid. Just 2 needed. One is KMNO4 and one is KCr2O7. KR2 K2Cr2O7. One is acidified alkaline and acidified potassium dichromate and acidified K2Cr2O7, that is potassium dichromate, and this one is potassium permanganate. Done. What are detergents chemically? This is the most important question. Higher fatty acids of sodium salts. हाँ जी इस टाइम दवाई का असर होता बहुत लंबा होता है। Okay, so carbon and its compounds. Now, when we see about them, what do you understand by these? These are functional groups. Okay, so functional groups. First, we will understand what is actually functional groups. So, biggest part comes in this chapter is what are functional groups. So the functional groups play a major role. Sorry. Sorry for the audio problem. So functional groups. There are basically 4 to 5 functional groups. We are doing one is the halo group. The halo group is the most important out of all, where we attach chlorine, bromine, iodine. So it has a prefix and no isomerism is possible. Okay, the next come in the chart is chlorine, bromine, iodine. When we write the formula in an alkyl group, so first the alkyl group is an hydrocarbon with reduction of one hydrogen atom. When we say that it's CH3, then it's an alkyl, means it's an not methane but it's an alkyl formation of methane. When it is CH4, it is methane. So the same concept applies. And when we see that, so what is C? When we add CH3Cl, then you get chloro 2 chloro नहीं sorry सिर्फ chloromethane, dichloromethane or 2-chloromethane. As simple as that. Okay, so the next one is alcohol. Alcohol is of two. So the next one is OH, alcohol. It has a suffix that is all. This is all, not all, it's all. Then you have CHO, one carbon plus HO. When you have this is all, means these are aldehydes. Aldehydes. These are alcohols. First, write all of them. One carbon atom, one oxygen atom, O N A. These are ketone. And lastly, it is COOH. Two oxygen atoms, one carbon atom, and one hydrogen atom, which leads at the end OIC acid need to be written in IUPAC nomenclature. These are carboxylic acid groups. Now we have done the functional groups. So the next thing is hydrogenation. Now hydrogenation is used for creation of vegetable oils and ghee. So hydrogenation is used for the vegetable oil or conversion of vegetable oil into vanaspati ghee. Like it is C double bond C 4-sided R. With this 4-sided R, you mean when we plus H2, then we get out with this compound. That is written right here. C H H H H H and H. It becomes CH3 bonds CH3. Now some examiners might not like that, then you have to do it like this. Similarly, these are R. R means any carbon chain. You thus need to sometimes add R2. Explained, okay? So we have done a esterification process, just that in the quiz. So that quiz was a refresher. We have discussed the cleansing action of soap in detail. We have done soaps. The next topic which is important is saponification. Now saponification is just a reverse of esterification, so not going in deeper with it. So with this we come to an end of this topic. In the next we will talk about some physical properties and some chemical properties of carbon. Till then, signing off.